Now let us see this question. A linear second order system with the transfer function g of s is 49 by s square plus 16s plus 49 initially at rest, and it is subjected to a step input signal. That means this system we have disturbed with the step input. The response of this system will exhibit a peak overshoot of. That means initially it is relaxed. When you suddenly switch on the supply, how much peak overshoot will get. Okay, so let us see. From the transfer function, what is the omega n? Root over 49. What is the value of root over 49? It is 7. Now what else left? 2 zeta omega n is 2 zeta omega n value 16. Then zeta value will be 16 divided by 2 into what is the omega n value? 7. So its value is, if you observe very carefully, 16 by 14. Its value is greater than 1. When zeta value is greater than 1, what would be the peak overshoot? Is it overdamped? So we know that peak overshoot generally represented with MP, e power minus 5 zeta by root over 1 minus zeta square. You take zeta value greater than any number, which is 1.1 or 1.2 or 2 or any number you take, which is in the denominator, you have an imaginary function, because root of negative sign indicates imaginary, right? So then this overall value, see wherever I'm highlighting, this overall value is going to be how much? This overall value is going to be how much? Infinity. Okay. So overall value is going to be how much? E power minus infinity how much? 0. E power infinity how much? 0. Therefore peak overshoot is going to be how much? 0. Is it clear? Therefore which option is correct? Peak overshoot. Okay. Now let us see another question. So if you see the question, the open loop transfer function of a unity feedback system g of s is given by this, and if the gain increases to infinity, then the damping ratio will be becomes, okay, if gain is infinity, what will happen? So first of all, take that g of s as it is here. We'll see what will happen. K by s into s plus 1. Now when you want to calculate the damping ratio, obviously you need the closed loop transfer function. So what is it? CLTF K by s square plus s plus k. Correct na? S square plus s plus k. But as per the given question, if gain k approaches to infinity, then what is the omega n value from this? Can I say omega n is nothing but root over infinity when k approaches infinity? So root of infinity how much? Obviously infinity. When omega n you got as infinity, then what is 2 zeta omega n s? Is equals to 1. So zeta will be 1 upon 2. What is omega n, sir? Infinity. Something by infinity value will be 0. So therefore the damping ratio will be how much? 0. Why? Obviously because the frequency, there is no frequency of oscillations. If there is no frequency of oscillations, means that system is called what? Sorry, frequency of oscillations are infinity. When the frequency of oscillations are infinity, means there is no scope of damping, right? So therefore this is called undamped system. Can we say that? Undamped system. Since the frequency is infinity, so therefore the frequency of oscillations are huge. So the system is completely oscillator. Okay. Now let us see another question. Now if you see the question, what is that? The open loop transfer function of a system is 10 by 1 plus s. Right? G of s is equals to 10 upon 1 plus s. The steady state error to unit step input when operates as a unity feedback. So we don't bother about the feedback system, because the thing is, our interest is always open loop only, because we are dealing with steady state error. We are dealing with steady state error. What type of input it is? Step input. So is it the type 0 or type 1 or type 2? It is type 0 system. And what sort of input you are giving to this? What sort of input you are giving to this? Step input you are giving. When a step input is given to the type 0 system, the steady state error is always finite. We don't know, we have to calculate that. Steady state error will be always finite. If the finite steady state error it is there, if finite steady state error it is there, how much it is? So first of all, let us calculate the Kp because it is a step input. For step input, we have to calculate the Kp. So can I say Kp is equals to limit s tends to 0, 10 by 1 plus s because it is a step input. So put that is going to be 10. But this is Kp only, but not the steady state error. This is where we generally commit a mistake. That is why they have given us an option. So that's why this is not. They are asking what? Steady state error. So what is the steady state error? Can I say steady state error is equals to 1 upon 1 plus Kp for step input. So what is this value? Upon 1 plus, what is the Kp value you got? 10. So 1 by 10 plus 1, which is nothing but 1 upon. This is the correct answer. Right? Now, let us see one more question. The dynamic equation of second order system is given like this. So in such a way, let us take as it is d square y by dt square plus 4 into dy by dt plus 8y is equal to 8 into x of t. But it is better to make it like a monic function. What is that? D square y by dt square, divide with everything with 2 plus 2 dy by dt plus 4y plus 4x of t. Correct now? Now what we need to do? Simply apply Laplace to this because any initial condition they have not mentioned. So what is this? S square plus 2s plus 4 which is equals to 4. Okay, anyway, let us put this is y of s into 4 into x of s. So what is the transfer function? Y of s by x of s is equals to, what is this? 4 upon s square plus 2s plus 4. This is what we got. We know that what is they're asking? Damping coefficient. Damping coefficient generally represented with tau is equal to 1 upon zeta omega n. What is omega n, sir? From this, can we say directly omega n is nothing but 2. And what about zeta? 2 zeta omega n equals to 2. From this, zeta is equals to 2 by 2 into, what is that omega n? 2, which is nothing but 0.5. Put here 0.5. So what is the answer you got? 1. So therefore option D is correct. Okay now? Okay, now let us see this question. What is they're asking? Consider the following statements with respect to the unity feedback system shown in the figure. Okay, so what is they have given? A block diagram, and they're asking set of points. So which of these points are correct with respect to this block diagram? So first of all, what is they're asking? Characteristic equation. Is it correct or not? Generally characteristic equation refers to closed loop, right? So what is the g of s they have given? Let me take the first one. G of s is equal to 16 by s square plus 4s.
I just multiplied that. Now what is there asking? Characteristic equation. What is the formula for characteristic equation? Characteristic equation is equals to 1 plus GS into HS, which is equal to 0. 1 plus GSHS equals to 0. So that implies, what is this 1 plus GSHS? So can I say 1 plus 16 by S square plus 4S into, what is the HS value? Unity feedback it is. Correct na? So we have to multiply with 1. So what is this value finally? Equal to 0. Therefore can I say, by rearranging this equation will be S square plus 4S plus 16 equal to 0. This is the characteristic equation of the given block diagram. Okay na? So therefore can I say first statement is correct? Yes. Now the second one, the loop transfer function. Loop transfer function only they asked. So loop, this is the loop. This transfer function is what? Loop transfer function. Loop transfer function, can I say it is nothing but GS into HS? GS into HS. What is GS into HS? Same, this one only. 16 by S into S plus 4 into 1, which is nothing but 16 by S into S plus 4. Therefore, can I say this option is also correct? Yes. Now the third one, the natural frequency of oscillation. So what is the natural frequency of oscillation? Natural frequency oscillation is equals to what? Omega n. We know that from the characteristic equation, we know how to find out the omega n. How to calculate the omega n? So this is nothing but omega n square. Correct na? From the characteristic equation also we can find second order system. So therefore can I say omega n square is equals to 16. From that, what is omega n? Obviously 4 radians per second. Yes, so option 3 is also correct, right? Now the fourth one, the damping ratio we need to calculate. So what is the damping ratio? How to define the damping ratio? From this only we can say na. So damping ratio we will be getting from this person, right? From this person we are going to get, right? So can I take like this? 2 zeta omega n is equals to how much? 4. Then zeta is equals to, from this, zeta is equals to how much? 4 upon 2 into, what is the omega n we got? It is also 4. So this value will be 0.5. But as per the given data, the damping ratio is 0.2. So therefore this is wrong. The steady state error to ramp input. So if you see clearly, what is the type of the system? Type of the system is 1. Type of the system is 1. And ramp. So definitely we will get finite error. So therefore we have to check whether this error value is correct or not. Finite error you will get. So therefore what is the type 1 and ramp input? What is the KV? KV is equal to limit S tends to 0 S into G of S. What is this G of S? 16 by S into S plus 4. Can we say that? So this gets cancelled, and finally what you get? 16 by 4, which is equals to 4. But this is not the steady state error. That is the KV, velocity error coefficient. But what we need to calculate? We have to calculate the steady state error. Can I say steady state error is nothing but 1 upon KV, which is nothing but 1 upon 4, which is nothing but 0.25. Correct? Huh? 1 by 4 is 0.25. So therefore this option is also correct. So out of 5 options, 4 options are correct except 4. Therefore can I say option B is correct? Yes. It looks like somewhat lengthy, but you have a good practice on these kind of models, you will be able to solve very quickly. Okay. So this is how we have to solve this question. Now let us see the next question. The given question as follows. The open loop transfer function of a servo system with a unity negative feedback system is given. It is an open loop transfer function. What is the damping ratio and natural frequency of oscillation in radians per second? Sometimes you need to check very carefully whether they are asking in radians per seconds or in seconds or what. You have to check. Okay. Now let us see. G of S they have given and with unity negative feedback. So whenever if you have a unity negative feedback, then what is the closed loop transfer function? Numerator will be as it is. Numerator will be as it is. So unity negative feedback means you add both numerator and denominator. So S plus 2 into S plus 5 plus 6. Now if you further simplify, 6 and this can be written like S square plus 7S plus 10 plus 6, 16. 16. Now can I say this is looks like our characteristic equation. From the characteristic equation we are going to find out the omega n. What is the omega n from this? Omega n is equal to root over 16, which is nothing but 4 radians per second. 4 radians per second. So out of 4 options we can straight away eliminate these two because 4 is only available in this. Now what about the other thing they are asking? Damping ratio. Damping ratio. What is the damping ratio, sir? Generally it is denoted with zeta, and which is how much? From the characteristic equation we know how to write. So 2 zeta omega n is equals to 7, then zeta is equals to 7 upon 2 into 8, which is nothing but 2 into 4, which is nothing but 7 upon 8. So therefore correct answer. But here sometimes we can easily calculate without doing this comparison, this and that. I will first see what is omega n. That is my primary objective, to calculate the zeta. Suppose once if I got here the same problem, I will take omega n, how much we got? 4 here we got. And now I want to calculate the zeta. Whenever you got any omega, try to multiply this with 2. After multiplying this with 2, how much you will get? 8 you will get. For zeta, always this 8 in the denominator. Now what else the value is left? 7. Right? Now in a smart way, how to deal with that? For example, instead of 7 here, suppose the characteristic equation is like this: s square plus 8s plus 16 we have. In this case, if you see, I know how to calculate the omega n. What is omega n? 4. What I told you? Multiply with 2. Now you check it. This number, is it equal to this number? Then it is critically damped. Now you see here, similarly, this 7 and this is 8. Can I say this is more than this or this is more than this? This is always less than this. So therefore, this is going to be underdamped. Suppose instead of 8 I have, for example, some 10. Obviously 10 greater than 8. That means overdamped. So without doing this analysis, just by looking into these numbers, we can say that. Okay. I hope it is clear. Now let us see the next question. A system is shown in the figure. The value of k, which gives steady state error 20% to a unit step input, is given. So what is they are saying? The value of k such that the steady state error is 20%. So that means they have given indirectly the steady state error to you and they are asking the gain k. So first of all, what is g of s? What is g of s? Can I say g of s is nothing but k by 1 plus s into 1 plus 4s. Can I say that? That is the open loop transfer function. And strictly speaking, what is the type of the given system? Always for steady state error, you better check every time type of the system so that you will never get any confusion. What is the type of the system? It is 0. So type 0 is suitable for what type of input to get the finite error? Step input. So fortunately, as per the given question, what type of input we given? Step input only, right? So 20% error is correct. Now let us see how to calculate that steady state error. So first let us calculate the Kp. What is Kp? Positional error constant, na? Limit s tends to 0, k by 1 plus s into 1 plus 4s. Now put s equals to 0. Now put s equals to 0, what you will get? You will get straight away k only. Now put this k in our actual transfer function, I mean like steady state error transfer function. What is that steady state error? Which is nothing but 1 by 1 plus kp, which is equals to how much? They have given 20%, which is nothing but 0.2, right? So kp or k both are same. 1 plus k is equals to 0.2. Now what is k? That implies 0.2 plus 0.2k is equals to 1. And from this, what is 0.2k is equals to 0.8. So therefore, from this, what is k? 0.8 by 0.2, which is nothing but 4, and this option is correct. What we did, simply first they are asking what, calculate the value of gain k, so that I got the steady state error is 20%. It's a different way of approach. Or in sometimes what they will obviously give the gain k something value, they will put 2, 3, 4, 5 something else, and they will ask what is the steady state error of this particular system if I give step input. But it is now reverse question. So they have given steady state error. So we have equated the steady state error equation to 0.2 to 20%, na? So by substituting these values, and finally we got the k value as 4. This is very important model which you can expect in GENCO and TRANSCO. Why? Because here people will feel more difficulty because multi-concept involved in it. Okay, so I hope it is clear. Now let us see the next question. Okay, it is also similar model. If you see, consider the feedback control system shown in the figure. This is the feedback control system. The damping ratio zeta for which the steady state error is 40% to unit step. So it is somewhat interesting. They are asking what is the zeta for which the steady state error is 40%. For which input? Unit step input. So first, to calculate the damping ratio, you need to write the whole transfer function. If you write whole transfer function, it will be in terms of s and k. So indirectly what they are saying, first you have to calculate with respect to this steady state error k. Once you calculate the k, substitute that k in this block diagram, and then we will get the closed loop transfer function. From that we can calculate the zeta. So let us see. So steady state error is 40%, na? So what is the steady state error? 40% means first you need to calculate the kp. What is kp? Limit s tends to 0, the transfer function, which is nothing but k square divided by 2 plus s into 1 plus 4s. Anyway, it is a type 0 system. So if you substitute this, what you will get? 2 plus s into 1 plus 4s. Put s equals to 0, you will get k square by 2, you will get kp value. Okay, what is the steady state error formula? Steady state error for step input type 0 system is 1 upon 1 plus kp, which is equals to how much? 40%, which is nothing but 0.4. 40% na? 0.4. That implies, can I say 1 upon 1 plus, what is this value? K square by 2 equals to 0.4. Now from this, can I say that k square by 2 into 0.4 plus 0.4 equals to 1? And from this, can I say k square by 2 into 0.4 equals to 0.6? And from this, can I say k square by 2 is equals to 6 by 4? And from this, what is the value of k square is equals to? And I can say that this is 2 times and this is 3, right? Then k is equals to root 3. And now, anyway, you can put directly k square also, is not a problem. So, what is the closed loop transfer function for this now? Finally, we got the k value, or you can say k square value, we got 3. Now, closed loop transfer function is equals to what? I can say, I can write directly like this. K square divided by, why? Because it is a unity feedback. K square divided by, yes, 2 plus s into 1 plus 4s plus k square, because negative unity feedback. Correct na? So now you simplify this, which is nothing but k square divided by, what is there? I can say 4s square, next s, this is s and this is 8s plus 9s plus 2 plus square, right? 4s square, 4s square plus s plus 8s, total 9s, 4s square plus 9s, 2 into 1, 2 plus k square. And what is the k value, k square value we got here? 3, because k into k na, k square value got 3. So 3 divided by 4s square plus 9s plus 2 plus 3. But it is not in our standard form. Standard form is what? S square plus 2 zeta omega n s plus omega n square. So what I can do, I will just divide this entire equation with 4. So this will be 3 by 4 whole divided by s square plus 9s plus 9s by 4 plus 5 by 4. Now what is the zeta calculation? We know that omega n is equals to root of 5 by 4. Keep it as it is. Now what is the zeta? 2 zeta omega n is equals to 9 by 4. Correct only na? 9 by 4. From this, can I say zeta omega n is equals to 9 by 8. But what is omega n here? Zeta into root 5. 4 if it comes out, 2. 9 by 8. From this, zeta is equals to, this is 4 times. So finally you will get what? 9 by 4 root 5. 4 root 5. So you can say easily that, it is overdamped. Why overdamped? You see, this is 4, root 5 value is just above 2. Just above 2. So 4 2s are 8. It means less than 9, definitely. Less than 9. So definitely 9 by something, that will be overdamped. You just check it. Okay. So that is how we are going to calculate. So this is involved in multi-concept. It means like, what are the concepts involved in it? 1 plus 1 concept involved. What is that 1 plus 1? First you need to calculate the steady state error. Then we need to calculate the zeta. because steady state error refers to open loop, zeta refers to closed loop. Okay na? So that's why you have to use sorry two concepts. Okay, I hope it is clear. Now let us see the next question. So what is they're asking? The steady state error of the system shown in the figure for a unit step input is. So first, to calculate the steady state error for the step input is, first derive the transfer function of it. What is the steady state error ka transfer function? First of all, E of S divided by R of S is equals to, tell me how many forward paths are there? Only one in the numerator. And what is the loop transfer function here? What is the loop transfer function here? 4 by S plus 2 into 2 by S plus 4, which is nothing but 1 plus, what is that? 4 by S plus 2, 4 by S plus 2 into 2 by S plus 4. You simplify this, what you will get? S plus 2 into S plus 4 whole divided by, just I am simplifying, that's it, S plus 2 into S plus 4 plus 8. This is what our transfer function. Now from this, what is E of S? This R of S should be multiplied. What is that R of S here? Here R of S is what? The step input. R of S is step input. Step input means 1 upon S. 1 upon S into this entire thing. What is that? S plus 2 into S plus 4 whole divided by S plus 2 into S plus 4 plus 8. Correct only, no? What is the steady state error? Steady state error for step input is equals to 1 upon 1 plus limit S tends to 0 into, or else you can write like this also. First you can take like this, limit directly you can put limit S tends to 0, S into this entire thing. What is this entire thing? S plus 2 into S plus 4 whole divided by S into this entire thing, S plus 2 into S plus 4 plus 8, putting inside the bracket. Correct na? Now just cancel this too, because it is a type 0 system. Now put S equals to 0 wherever S is there. 2 into 4 divided by, what else left? 2 into 4 plus 8, which is nothing but 8 by 16, which is nothing but 0.5. Therefore, steady state error is, they have not mentioned about what is the percentage. So we have to write like 0.5 only. Suppose if they are very specifically mentioned, if it is a percentage, then what is your answer? If it is percentage, then it will be 50%. Okay na? So what we have done, so generally where we commit a mistake, lot of chances are there. Steady state error means obviously we will take this one, but actually the thing is, its feedback is also involved in it. Whenever feedback involved in it, you better get the transfer function of it. It will not take much time, just you will write one forward path, one loop, right? So you will get the transfer function. So once if you get the transfer function in terms of, you know, error with respect to input, and from this error I will take what is the input as per the data, multiply with that and rearrange it, and I will get some equation like this. And steady state error we know, for step input, limit S tends to 0, S into this and gets cancelled, and 8 by 8 plus 8, 8 by 16, 0.5. Provided you have to check what are the units they have mentioned here. If they have not mentioned any units here, like in terms of percentage and all, just keep it as it is. If it is mentioned like percentages, you have to be very careful. Okay? I hope it is clear. Now let us see the next question. So if you see, as per the given question, the open loop transfer function of a unity negative feedback, if they have mentioned like unity feedback means obviously it is a negative feedback system only, they have given open loop. And for the peak overshoot of the closed loop system for unit step input is 10%. That means they have given peak overshoot of 10%. What is the value of k? So as per the data, g of s is equals to k upon s into s plus 2. This is open loop. But they are telling that peak overshoot of closed loop system is 10%. So first let us write the closed loop transfer function. As it is k s square plus 2s plus k. What is peak overshoot? First calculate omega n. Omega n is root k. Correct? What is peak overshoot? 2 zeta omega n is equals to 2. Then zeta is equals to 1 upon root k. That's it, na? 2 gets cancelled. Zeta is equal to 1 by root k. So once you got 1 by root k, what is the peak overshoot? We know that e to the power of minus pi zeta by root over 1 minus zeta square, which is equals to, what is the zeta? 1 upon root k by root over 1 minus 1 by k. Why 1 minus 1 by k? Zeta square, na? Which is equals to how much? 10%, which is nothing but 0.1. See, one equation, only one unknown. So by calculating this, after simplifying this k value is, you will get 2.8. Means like you have to apply the natural logarithm and all. Okay, na? K value you will get it for how much? 2.8. Okay, I hope it is clear. What? Nothing we did, just we have calculated the omega n and zeta and substitute the zeta value here in terms of k, and they have given anyway the peak overshoot, the percentage, and we use that and we have calculated the k value. Okay? So therefore answer is how much? K value 2.8. 2 decimals means 2.80.